Hello everyone, we are on lesson 83. You're going to need your pencil, a red and yellow colored pencil, possibly a red and yellow marker, and your booklet, your energy booklet, electricity booklet. Okay. So in our last science lesson, we learned about light bulbs. So let's just review what we learned. Look back in your electricity booklet and open it up to page 7. So we learned about incandescent light bulbs. So looking at the words here on the left, do we know on which part of the light bulb that we could label these as? The filament. That's one of the parts of the incandescent light bulb. It's the part that gets hot in the coils. We have our lead wires. Screw cap. And then we have our tip. Can anyone remember anything about a halogen light bulb? It's very important not to touch the halogen light bulb. And it gets very hot, but they last for a long time. So what are the 4 types of light bulbs? Incandescent, halogen, fluorescent, and LED. And we know of the uses, advantages, and disadvantages of these bulbs because we learned about them on page 7. A battery and an incandescent light bulb to make a closed circuit. Now, in this example, you see I have a dry cell battery and an incandescent light bulb. Now we're going to try to light the bulb by using the battery. There's nothing that happens. So were we able to light the bulb? No. Now the light bulb did not light because the electric current couldn't move from the negative terminal of the battery through the bulb and into the positive terminal of the battery. Now we are going to try this with an electrical wire, so we will use the wire and battery to light the bulb. We're going to place the wire underneath the battery on the flat side of the battery, which is the negative terminal. And then we will place the tip of the bulb on the positive terminal of the battery. And so what do you think the other end of the wire needs to touch to make the bulb light? The side of the screw cap. Yep. So what happened now? The bulb lit. The electrons in this closed circuit are moving from the negative terminal of the battery through the wire into the screw cap of the bulb, up through one of the lead wires, through the filament, down the other lead wire, through the tip of the bulb, and into the positive terminal of the battery. Now, we're going to try moving the tip of the bulb onto the metal around the positive terminal of the battery. And what happens? Well, the bulb lights up again. So now we are going to try moving the tip of the bulb to the plastic coating on the side of the battery, which may be a little bit hard to see here. But do you see anything happening? No. The bulb, once again, on this example, did not light. So the plastic coating acts as a insulator. Yes, insulator. So now turn the bulb and place the side of the screw cap on the positive terminal. So what do you think the other end of the wire needs to touch to make the bulb light? we turned it on its side.
The positive point to the battery of the bulb.
Okay, so once again, how are the electrons moving in this closed circuit? From the negative terminal of the battery through the wire into the tip of the bulb, through one of the lead wires, through the filament, down the other lead wire, through the side of the screw cap, and into the positive terminal of the battery. Now, we're going to just try some different ways to try to get the bulb to light. So watch as we demonstrate a few different examples that we have for you. Okay, so what happened there? Did you flip it over?
Turn the battery over, and we got the wire going to the positive point on the battery, and we tap the bulb going from the positive tip of the bulb to the negative on the battery. And we put the wire to the side of the bulb.
The screw cap?
The screw cap.
And it's still lit?
And it still lights, yes.
Okay.
Then we can do the same thing by turning the bulb on the side of the screw cap, going to the negative part, and taking the wire and putting it to the...
Can you turn your fingers a little? There you go. Okay, so that still lights too?
Yep. Still a complete circuit.
Okay. So basically, every way that we put this light bulb on this battery will cause it to light nearly, except on the plastic part?
No, negative. If you take the screw part of the bulb and put it on the positive terminal of the battery, and then you touch the wire coming from the negative terminal on the battery and put it to the screw cap of the light, it's not going to light, because that is not completing a circuit from the positive terminal to the negative terminal of the battery.
So we just wanted to show you how you can have different applications, different types of bulbs, and different types of batteries to create a circuit and light up different bulbs. This here light bar, wand, whatever you want to call it, has LED light bulbs in it, which is light emitting diodes, and it is hooked up to a 9-volt battery.
So here we have different types of insulators. Insulators are devices that do not allow electricity to flow through them. These are just some different insulators off of different overhead applications. You might have seen some of these, like this one here, on the power lines you see around town and around next to the road. This one here is definitely a modern day insulator, very large for high voltage wires. These here insulators are off of an overhead power line, but it's a very much smaller line, and these are very old, as you can tell. They don't make these anymore.
How does the wire hook onto them?
The wire hooks onto them right here. They take and have a clip that goes around the wire and the insulator like that. The big one I showed you right here, the wire simply just lays across it like this, like this.
And those are mounted onto poles?
Mounted on, yes, poles that hold the overhead power lines off the ground. This one is also mounted to an overhead power line, but it is for the grounding cable on the overhead power line. It's not near as much insulation material as there is in this one versus this one, because the cable this one insulates does not have any power going through it.
Okay, using your red marker, make sure you're looking on page 8. And I'm going to trace the path of the electrons through this circuit. The electrons flow from the negative terminal. So in the first diagram, you will use your red colored pencil to trace the closed circuit from the negative terminal of the battery through the wire, through the bulb, and back to the positive terminal. So let me get my red colored pencil here. So we start here and come up, it comes up like this in this direction. Okay. And it goes up through the lead wires, through the filament, and back down to the screw cap. So whenever that happens, we get our light. Now, on this one, it leaves the bottom of the negative terminal and comes in through the bottom here, not on the plastic of the tip. It's on the tip, but not on the black plastic part. And then it goes up through one of the lead wires, through the filament, and then back down, which is, of course, laying on top of the positive terminal. Therefore, that gives us light. The directional path that it follows, is as such. Okay. Now, down here, okay, we have, get my drawing tools. We have, once again, we have the wire put on the side of the screw cap, and we're coming up here to the positive side. So the directional path is like this. Remember, whenever he flipped the battery over, basically this is the same scenario. Of course, it starts out being here on the negative side, so it comes up through this filament, back down, and then through that way, in order to give us our light. And then lastly, we are leaving the positive end, coming here from the negative end on the tip, and the path of flow is like this, up to the positive end of the battery. So by it starting here, it comes up through the lead wires, through the filament, back down, and out that way in order to give us light. Please make sure you have those marked. In our next lesson, we are going to learn how to use 2 wires, bulb holder with an incandescent light bulb, and dry cell batteries to make a closed circuit. Now remember, most wires are made out of copper and aluminum. And in order to have a closed circuit, which means it would light, okay, we have to have a complete circuit going on here. If it's an open circuit, there is a break in the line somewhere. All right, good luck. You have a lesson to do. Ask your teacher if you need help.